These are the newest images of 3i Atlas from yesterday, and I'm pretty sure this is actually the most shocking anomaly we've seen about this object, because the only possible explanation until now was that it's breaking apart. So in this video, I'll break down everything we know about what's actually happening with 3i Atlas. So let's first talk about why everyone was convinced that it should be fragmenting or breaking apart, and then we'll talk about what the newest images actually reveal. So on November 9th, we captured these images showing a tail and a sunward tail extending millions of kilometers. But for comets, gas flows out at only about 1,500 kilometers per hour. That's pretty slow for space, so for the tails to stretch out millions of kilometers at that speed, the comet would need to be shooting out gas constantly for a couple of months. But images from just a few days earlier showed absolutely no tail at all, which is just one of the weird parts about the tails. The comet would need about 1,600 square kilometers of surface area absorbing sunlight. That's the same as a sphere 23 kilometers across. But Hubble measured 3i Atlas at only 5.6 kilometers across. The math showed us it needed to be 4 times bigger than what it actually was. So we calculated how much material these tails must be carrying away from 3i Atlas, and the numbers are pretty shocking. Estimations showed us 3i Atlas has to be losing about 50 billion tons of material per month, which is pretty disturbing considering the object is supposed to weigh only about 33 billion tons. But we have actually seen this before. The comet Shoemaker-Levy 9 broke apart in 1992, and the total amount of material it released was way more than what we thought the original comet weighed, but that made perfect sense once we realized it had broken into 21 different pieces. These pieces then have more surface area for the sun's heat to cause more ice to turn into gas, creating more visible jets and tails. So the only logical explanation for the 7 jets seen on November 8th and the massive multi-million kilometer tails in the November 9th images was that 3i Atlas had fragmented into different pieces, because there is no way a solid object can lose more mass than it weighs. So let's talk about what the new images actually reveal. On November 11th, 2 astronomers named David Jewitt and Jane Liu pointed a telescope in the Canary Islands at 3i Atlas. When they published their findings, they gave it a very simple title: 3i Atlas Still Single. So not broken into pieces, not fragmenting, not scattering debris everywhere. But here is what makes these images so important. They did not just look and say, yep, it is still together. They actually measured and analyzed everything in detail. The images show 3i Atlas is about 1.5 astronomical units from the sun. That's about 214 million kilometers. And it's a little over 2 astronomical units from Earth, which is about 320 million kilometers away. They observed a region around the comet that was about 500,000 kilometers wide, so they were looking at a huge area to find any signs of breakup. What they found was one single bright nucleus. That is the solid center of the comet. Around it is an active glowing cloud of gas and dust called the coma. The coma has a complex shape with different structures in it. They saw 2 tails pointing in opposite directions, just like we saw in the previous images. One tail is pointing almost directly toward the sun. They measured its angle at about 106 degrees. The sun was at about 115 degrees. So this tail is pointing at the sun with only about a 9-degree difference. This is called an anti-tail, and it's pretty rare but not impossible. The other tail is pointing away from the sun in the normal direction at about 301 degrees. They used different image processing techniques to look for fragments. They stretched the brightness, they made contour maps, they used false colors, they looked at the image in rings moving outward from the center. Every technique they tried was designed to find even small pieces if they were there. They specifically wrote in their report that the imaged region showed no hint of fragmentation. If 3i Atlas had broken into 16 pieces like the math suggested it should, those pieces would be spreading out, they would be visible, they would leave trails, but the images showed none of that. So we are not just saying the object looks like it held together. We are saying astronomers carefully examined a massive region around it using multiple analysis methods and found zero evidence of any breakup whatsoever. And remember, this object just went through the most intense part of its journey. It passed closest to the sun on October 29th. It got heated to extreme temperatures. We expected the thermal stress alone to have cracked it apart, the pressure from all that gas shooting out to have blown it into pieces. But 2 weeks later, it is still one solid object actively producing enormous jets in multiple directions. So if the object really is natural, which I think it is, scientists need to explain how this is physically possible. Here are the theories I have as of right now. We know 3I Atlas is probably billions of years older than our entire solar system, maybe 7 billion years old, maybe 10 billion years old. For all those billions of years, the comet was flying through deep space, getting hit by cosmic rays. These are high-energy particles that slam into objects and change their chemistry. Think of it like radiation, slowly cooking the surface over billions of years. The James Webb Space Telescope found something interesting that supports this idea. 3I Atlas has way more carbon dioxide compared to water than normal comets, about 8 times more than the usual ratio. This could be because cosmic rays converted carbon monoxide on the surface into carbon dioxide over billions of years. These cosmic rays could have also created a weird crusty layer on the surface. This crust might make the ice underneath sublimate in really strange ways we have never seen before. Maybe it creates channels or pockets that give the comet way more effective surface area than we can see from the outside. Another one is that maybe we are calculating the needed surface area incorrectly. Maybe sublimation can happen faster than we think under certain conditions. Maybe the jets are not carrying as much mass as the calculations suggest. The 50 billion tons per month number came from looking at how big and bright the tails are and calculating backwards to figure out how much material must be there. But maybe the tails are just really good at scattering sunlight. Maybe they look bigger than they actually are in terms of mass. If the real mass loss is only 5 billion tons per month instead of 50 billion, the numbers would work much better. That is still extreme, but at least possible for an object this size. The problem with this theory is scientists have been calculating comet mass loss this way for decades. The method works. So if it is suddenly wrong for 3I Atlas, we need to understand why. If you watch to the end, drop me a like and subscribe for more updates.